Assalamu alaikum. So this particular lecture talks about, in fact, this particular chapter talks about determining boundaries. And the name of the chapter is Edge Detection and Segmentation. Now, we need to determine boundaries in an image if you want to determine or differentiate different objects which are present in the image. Now, it's usually done by two ways. One is edge detection and the other is segmentation, which in fact are very similar techniques. In edge detection, what you do is you try to explore the differences between the pixels, between the neighboring pixels, and that's why it's called edge detection. And when there are differences, then they are amplified. Now, segmentation is the other side of the coin, where you try to explore boundaries by looking at the similarities between neighboring pixels. Now, they both work. I mean, if you really think about it, it's just two sides of the coin. One is the head and the other is tail. Now, we will start discussing edge detection first. Now, this is a clip from the very popular movie Batman, and this gentleman, well, he is not alive anymore. And so we need to extract edges, and we need to determine these edges for a number of applications. You could look into document analysis, for instance, determining how different characters are differentiated from one another. One very popular project that electrical engineers usually make in their capstone design is a line following robot. I usually see that every year or every other year, somebody's making a line following robot. Or even image in recognizing different objects in classification. So we get these different edges because one is called surface normal discontinuity, where the surface itself changes. The other is depth discontinuity, because not everything is at the same depth level. And obviously there are different colors, that's why we have edges, and there is a difference in illumination. So something is in the front and the other thing which is at the back is the shadow. Now, how can one really determine if a pixel is an edge? Well, if you really think about it, if you're moving from if I'm moving this particular cursor, while I move this, the pixels over here have pretty much the same gray level, all of them are white. But suddenly there's a sharp increase. If you look over here from going left to right, there's suddenly a sharp increase, or you could rather not use the word increase, but rather there's a huge sudden change in the gray level. And effectively this change is what you need to determine, and that is again a gradient or a derivative. Now, in other words, what you see here is edges, when there is a smooth region and it's pretty much present at the same gray level, and then there's a huge cliff. Now that cliff means, or technically shows, there is a significant change in the gray region, gray levels, because a lot of these images we're looking into RGB values. You're looking into gray levels, but it doesn't have to be considered in that fashion. It could be, even in different colors. So when you talk about the gradient, because it's an image, it has an I and J, or it has an X and Y domain. The gradient is defined as the change in the pixel density, or the change in the color pixel, or the gray level, both in X and as well as Y direction, because it's an image, it's two-dimensional image. Now, this particular is an example where the rate of change is only in the X domain, because in the y, if you look here, it's pretty constant along the y. So the rate of change is 0 along the y domain. Here, if you look in the y domain, there is a rate of change in y, but in the x domain, it's pretty much constant, so it's 0. But over here, the image changes its gray level. So the gradient in this case is a combination of x and y. And that's the magnitude, and there is an angle to it. So you see here, the edge strength is determined by the gradient magnitude, and the angle is determined by the change in y over change in x, tan inverse of that. Now, the concern is that what you really have are just values. And how do you determine the gradient in those values, or how do you determine the derivative in those values? Well, the answer is you take the finite difference. For instance, in the x domain, the y remains constant, and what you're really comparing is the pixel on the right with the pixel on the center, as is shown here. In other words, if you want to compare x, you're going to compare it with x plus 1. So you're not really interested in y, and that's why y is constant, but it's really in terms of finite differences. Now obviously, for an image which is both x and y domain, it's a combination of both, and that's why you take the gradient, you take the magnitude as well as the direction. Now for edge detection, there is the Sobel edge detection, the Laplacian of Gaussian, and the canny edge detection. This particular lecture, we're going to focus on Sobel, and the next two lectures, we will tell you how to improve Sobel detection by introducing noise. So what happens when you introduce noise, and how does Sobel behave, and why does it make sense to go towards Laplacian of Gaussian, LOG, other words, and canny edge detection methods. Well, the way Sobel edge detection works, it really is a simple 3x3 mask, where you have a boundary, and assuming this is your edge, and what you're really doing is you magnify the difference on the points on the pixels opposite to the boundary, whereas you eliminate the similarities at the same level, on the same side of the boundary. So Sobel edge detection comes both in horizontal with vertical Sobel edge detection. This is an example of horizontal. So this would be your boundary. You can see there is an entire row which is zeros, and the opposite pixels, the pixels lying opposite to this boundary, the difference is magnified, and that's why you have this 3x3 mask that looks like this. In a vertical Sobel, so horizontal Sobel edge, this is the original image, this is your boundary. So as you can see here, the image is opposite to that, the boundary is magnified, that's why the gray level is white in color, whereas the elements which are present on opposite sides, they kind of like the differences are eliminated, it's smoothed out in some sense. So Sobel horizontal edge detection is good for horizontal edges, but for vertical edges we use vertical Sobel edge detection, where there is zeros in the center plane. You can see there's a column which is all zeros, and the pixel lying on opposite sides of this boundary, those differences are magnified. Now one thing which is worthwhile mentioning is that images are not always horizontal and vertical, rather they're a combination of both. And that's why normally what you do is you take the combination of both, and you really detect edges in smaller blocks, and they're combined with other smaller blocks to determine really the boundaries for the whole image, in the complete image. So this is how in MATLAB you just read the image, and then you convert the colored image into its gray scale. You show the image. Now this is the function which is used for edge detection. Now you would see you have the image I here, so its edge where you're giving the image I and you're trying to use Sobel edge detection. But if you intended to use Laplacian of Gaussian, you would simply put within single quotation marks, you would put LOG. If you wanted to use canny edge detection method within single quotation mark, you would simply put canny. So now you can see here, so in one sense, the primary function in MATLAB for edge detection is the function edge. We give the image and then you specify what type of edge detection you're really interested in. In this particular case, so this is the image of an individual, and that's the Sobel edge detection on that. Here is the same for heart. So in the next particular lecture, we're going to talk about what happens and how you can resolve the instance where you add some little noise in the image. Now, when you add little noises in the image, though, you technically have gradients that appear all over the place. And that is something which is usually needs to be smoothened out first before you do anything with it. That's enough for this lecture. Inshallah, see you next time. Have a good day.